The next ones, we are actually going to set up the formula that we need to evaluate then for exponential growth or decay. It says a car is purchased for $28,500. After each year, the resale value decreases by 35%. What will the resale value be after 4 years? Round your answer to the nearest dollar. So our amount is going to be equal to, I'm going to call it the principal, whatever number you started with. Then you're going to have your rate. Your rate has to be the rate that you're retaining each year. So in this case, if I'm decreasing by 35%, what percent am I retaining in its value? It decreases by 35. What does it maintain? 65, right? So our percent's going to be 65 that we're going to use. And then it's going to be to the t power. So we're going to take 28,500 times 0.65 to the 4th power. Round to the nearest dollar, it says. Yep. So 5,087. So we bought a car for 28,500, and after 4 years, now it's only worth $5,000. Hopefully it retains better than 35%. That's not very good. Number 11, it says amount of $27,000 is borrowed for 10 years at 3.5% interest compounded annually. If the loan is paid in full at the end of that period, how much must be paid back? Since this is compounded annually, we don't have to use the compound interest formula. We're basically just using the same formula. And so we're saying $27,000. But we have to be careful on our interest, because our interest, we have the full amount that's in there plus the interest. So for our rate that it's retaining, it's 1.035. 100% plus the 3.5 interest that it's earning, right? We don't lose the money we first put in there, or we don't get to not pay that back. We are going to put that in there for 10 years, so to the 10th power. So whenever you do interest, where it's maintaining its full value, you're going to take 100% plus what the interest is, and that's going to be the interest that or the amount that it retains for the rate. 27,000. 1 plus 0.35 to the 10th power. And we are rounding to the nearest dollar. $38,086. So we borrowed $27,000. Our interest rate was pretty good. After 10 years, we pay $38,086 back. And number 12 is one of those with the half-life. The half-life of a radioactive isotope is the time it takes for a quantity of the isotope to be reduced to half of its initial mass. We're starting with 160 grams. How much will be left after 3 half-lives? So 160 grams. And in here, half-life, you can either use 1/2 like they did previously, or 50%, right? It's retaining 50% of its value. And I like to use 50% because 0.5 is easier to type in than 1/2. Not that it makes any difference. And then for 3 half-lives, so we're going to put a 3 up there. Ada doesn't want to answer anything. 20. So what happened, it started at 160, it cut it down to 80 in 1 half-life, 40 for the next one, and 20 for the next one, right? I could have done it that way. That's what half-life means.